Okay, now you might say, well, what are you going to do with your scale? So now you have a scale and you can give it to people and you can tell the difference between the fun people and the not fun people. And so what might be some practical purposes towards which you could put that knowledge? You don't have to be too serious about it. I mean, what are you gonna? You could invite all the non-fun people to a party. That would seem rather counterproductive. Your hypothesis would be that maybe you'd have two parties. You'd have a party with all the fun people, and you'd have another party with all the non-fun people. And then you could get the attendees to rate how fun the party was. And then that would help you determine whether or not your measurement of fun was actually practically useful for something. That's called criterion-related validity, by the way. So, and criterion-related validity, if a scale possesses criterion-related validity, you can identify something that it might predict that isn't like completely obviously associated with the initial measure, although, you know, fun at a party probably are, so that's a bad example. But you can use it to predict something that might be of value. So I can give you an example of that, is that conscientiousness, which is a trait, is frequently used to evaluate how good an employee might be if you hired them, or even how good a student might be, because conscientiousness turns out to be a pretty good predictor of academic achievement. Okay, so if you're going to make if you want to make a questionnaire, and some of you will do this when you do your honors thesis, or if you're involved in research at all, and people tend to think about developing a questionnaire as something that's relatively straightforward. It's not. You need to figure out what it is that you're after, you know, what's your central construct of interest, and then you have to figure out, well, how do I generate a very large number of items that hypothetically measures this, or its reverse, or its opposite, it doesn't really matter, and then a bunch of items that don't measure it, because again, you have to show that it's good for something and not good for everything. So, and then you have to demonstrate statistically that your concept is coherent, and then you have to show that you can use it to predict something. And it gets worse than that, actually. Then you have to show that it predicts something better than some other thing that someone already invented. So, you know, if you came up with a fun scale, it's probably primarily extroversion, that, as you mentioned, that a scale like that would measure, although it would be a little complicated, because generally fun people also have less negative emotions. So what you'd end up with, as we mentioned before, your fun scale would be a mangling up of a couple of different categories, and so it would probably end up not being a very good questionnaire at all. So it's a tricky thing to make a questionnaire. It takes an awful lot of work, and you can't start with the assumption that just because you've been able to think up a concept that it actually constitutes a concept that meets the criteria for scientific evidence, or for scientific category. So we should also talk maybe a little bit about some different kinds of categories, because it's not all that obvious to people that there are different kinds of categories. So I can name three very rapidly. There are many others. The first category, and these are usually the categories that scientists do investigate, they are technically called proper sets. And so a proper set is like the set of all triangles. And triangles are clearly not squares. We'd all agree on that. So what makes a triangle different than a square? Which one? Okay. I was just trying to trip you up there. So, okay, so, and is that true of all triangles? Right. What about a triangle that like is open on one line? Does that qualify as a triangle? No, it just looks like a triangle. It's like an imposter. So, okay, so a proper set has this interesting characteristic, which is it has absolutely clear inclusion and exclusion criteria, and there are no exceptions. And so, or almost no exceptions. So you might say, well, is the set of all helium atoms a proper set? And the answer to that fundamentally is yes. And it's distinguishable, say, from the set of all hydrogen atoms or the set of all iron atoms. There's characteristics that you can define that precisely indicate the boundaries of the category. And those sorts of things are relatively easy to study scientifically, because they tend to behave similarly in different circumstances.